Okay, now we consider problem 7.1. Okay, it says here a rectangular beam of 16-inch width carries a maximum moment, which is positive, of 592 kip foot. Fy is 60 psi and F prime C is 5,000 psi. Find the effective depth required for this speed if rho is set at 0.0125. So we have our rho already. So we are asked for the effective depth T. Okay. Now maximum moment that it should carry is set already also. That's 592 kip foot. Yan na, no? We substitute that to mu. Now, if we want to get your MR, because we need MR for this formula in getting the D or the effective depth. So divide mu by 12. Sorry, multiply. Okay, we multiply it by 12. So you get kip foot. Sorry, from kip foot, magiging kip H. Yeah, so it's 7,104. Now, from this formula, we have to get your R. No? Yung R, this is this formula from the original MR. No? R, we designated R with this formula. Rho Fy times the quantity 1 minus 0.59 rho Fy over F prime C. Okay? So to get R, we just substitute those values. So rho times Fy, okay, times the quantity 1 minus 0.59 rho times Fy over F prime C. So you'll get R be equal to 0.67968. Okay, now we're ready to compute for our D, which is the square root of MR, ito yan, no, all over phi multiplied by B, the width, times the R, the computed R. And you get 26.94 inches. Okay. Actually, you should get the same value if you use this there. 26.94. Kasi ito yung converted. So yung F6 times 12, ito yun. Okay, so you get 26.94 as your effective depth. Now, of course, you are rounding up no, kapag if you are setting your depth, pag inalis mo yung decimal number, you have to round up so that you provide more strength. Okay, so effective depth is 27 inches. Now, determine the minimum effective depth needed if rho can be changed. So, pwedeng palitan yung rho. What's the minimum? Okay. If you want the minimum effective depth, what do you want your rho? Para minimum mo yung, minimize mo yung part ng concrete. So you have to add steel, no? So, there. If you are adding steel, that means you are increasing your raw. If you're increasing your raw, iset mo siya to maximum. Okay? So raw max from the table is 0.0251. Okay? 60 from 60 KSI FY and then F prime of C5, you have your raw max to be 0.0251. Okay? So if we set that there, then applying the formula, okay? Pareho lang, no? Pareho lang yung MR, of course, the resisting moment. Then what would be the effective depth? Ito yung minimum na. Okay, 20.09. Now, let's compare the area of steel. What's the formula for area of steel? So this is equal to B times D times rho. Tama? So this is the area of steel, 5.38, 5.39. What about for this? Equal to B times steel times rho. There, ito 8.06. So notice the difference, no? This should be higher. You should have a greater steel area. Dahil iniiksian mo yung ano eh. I mean, you are reducing the depth of the beam. No? So that's the effect. No? You must use more steel to reinforce your beam. Okay? Did you get that? Any question? Question? Class? Adrian, you have any question?
Wala po, sir.
Okay, good. Angelica?
Okay na.
Okay. Piula, do you have any question? Ms. Perez, do you have any question? Okay, let's proceed to 7.2. So it says in the problem, a simply supported beam of 15 inches width is 20 feet long and carries a uniform service dead load of 2 kips per foot and a concentrated service time load of 30 kips at mid-span. Okay, assuming an effective depth of 30 inches and an overall depth of 34 inches, determine the steel ratio required at mid-span. Okay, let Fy equal to 60 KSI and F prime C equal to 3000 PSI. Okay. So how do we do that? So we have a simply supported beam 15 inch wide. So B is 15 inch. And then D is effectively assuming it's given. Of course, you also have H, 34 inches. Notice the difference between H and D. H, that's the overall height. Overall means pati yung cover. Okay? Yeah, and then Fy 60, F prime C is 3, okay, A is 0.9, of course, and then your length is 20 feet. Was it mentioned here? Yeah, 20 feet long. So meron. Okay, now you're being asked still ratio required. So you are asked for the still ratio. Hmm. First, we compute for M, no? MU particularly. Now, to get MU, you get K10 times 12. This is K. This one is, mhm, okay. First, we have to compute for the self-weight. Self-weight mo, as usual, note this, 150, that's the unit weight of concrete. And 144, conversion from inches to or square inches, no, to square foot. And then 1,000 from pounds to kilopounds. Okay, that's how this 0.53125 was obtained. So this is called out dito sa MU. Now, yung concentrated load is 30 kips. No? And you also have a dead load aside from the self weight. You have a dead load of 2 kips per foot. So these three, okay, are uh, are accounted for. Dead load, okay, nabanggit yan dito. It says uniform service dead load of 2 kips per foot. And then concentrated service load of 30 kips. Okay, at mid-span yan. That's, so the formula for that is 1.4. This is the factor for dead load. So K11, K14, that's the address of the self weight and the dead load here. So yung 2 at saka yung 0.53. Okay, that's the W. No? W because they are uniform load. L squared G, G8. Saan yung L? Ito, 20. G8 is 20. No? L squared over 8. And then plus the concentrated load, 1.7. Okay, the factor, because it's a live load, L P, which is 30 kips. Yan, yung P, tapos L over 4. Okay, so accounted for na yung tatlo, no? So these three are accounted for. Yeah? Now, multiplying that by 12, you get 5,186.25. Okay, now, how do we get yung raw na 0.079? 0.0079. Okay, we look that up sa table. Using the table for R and raw. Okay. So that this will be satisfied. Itong 432.1875. Okay. Hanapin natin yung table. Let us show the table para okay, we are looking for R to be 4.426 and your Fy and F prime C is 60. So this one, no? So 0.426 here. 0.426, it's between 0.079 and 0.0078. So we choose 0.0079. Okay. How did we do that? Ito, no? Ano? Okay. Did you get that? So that's how you use your this table. No? First one, you have to consider this. No? Dapat pareho yan dun sa problem natin. Prime C is 3,000 PSI. Your Fy is 60 PSI, 60,000 PSI. Okay. So we got 0.0079. 0.0079. We choose that. And then we try getting the MR. So having that MR, kompleto naman yung data natin. We get 5,222.23. Now divide that by 12, you get 435. Okay, now this 435 satisfies this, or it's greater than 432.1875, which is the required moment. Okay? Any question? Did you get how we solved it? Sundan ninyo? Okay, good. Dali. Tumiwan yata tayo ng isa. Okay, anyway. Now let's proceed to 7.3. Says determine the effective depth required for the cantilever beam of example 7.5 if a lower row value of say 1/2 rho max were to be used. Assume that all other conditions are unchanged. Now, if you look at example 7.5, okay, I have to refer to that. Sandali, 7.5. Kanina naman ako nag-share. You are screen sharing. Example 7.5. There. Ito yung example 7.5 natin. There. Determine the approximate required depth of a cantilever beam. Now, this is the solution. Excuse me. Okay, so B is 16 inches. Our rho is 0.5 times rho max. So rho max is 0.0213. What's the problem? Okay, the rho is actually 2/3 rho max. So it is just asking us what happens. No? So rho max is 0.01065. So now, what will be the effective depth required? So from the problem, what we got is what? What's the effective depth here? Okay, so from 27 again, it became 30.69. Okay, so reducing the still ratio, okay, will require greater depth. So from 27 again, 30.69 na siya. So that's what happens here. Just like the other problem in chapter 6. No? If you increase the increase the depth, what happens to your required steel? Any answer? Nababawasan po yung required steel. Correct. Okay, at least you understand that very well. Okay. Okay. For this one, okay, I hope you have submitted already ang assignment nyo dito. Now, for the double reinforced beam, this is the cross section. You have 3 number 11 for the tension reinforcement, and then 2 number 8s for the compression reinforcement. Okay? And then effective depth is 20 inches. B, or the width, is 11 inches. Okay? So yeah, they're all there already. A prime of S is 1.58. AS is 4.68. F prime C, 5,000. Excuse me. And then Fy is 60,000. Sorry, 60,000. Fy is 60,000 psi. Now, condition one, our assumption is that your F prime of S, the stress for the compression and tension reinforcement reaches the yield point. So that's equal to 60,000. Okay, and your condition one. Now we will have to check it. Now, so we have here or we have this formula. So yung assumptions natin. Now, having this, we have A is equal to 3.978. C is 4.973. And therefore, applying the formula, we get the value of our C, which is 4.97. Okay. Now, checking that, it won't be consistent. No? So that means yung epsilon prime S epsilon prime S says here no good. Bakit no good siya? Because our epsilon y is 0.002. Now, our computed epsilon prime S is 0.001. That means it is lower than epsilon y. Okay? Uh, sorry, a few seconds again. Sandali lang. Hello. Yeah. Uh-huh. So, our beta 1 is 0.8 now. This is according to the value of our f prime of C. Okay. And having this condition that actually the compression reinforcement is not yet yielding. So actually it is in condition 2. Since it is in condition 2, okay, we use this formula. No? Ito ang gamitin nating formula. So applying this formula, your A is 37.4, your B is, sorry, I might confuse you. I have to change this to a small letter. Para consistent tayo sa what's in the formula. A is this part, B is this part, and then C is this. No? Okay. Now, we will have to get the solution. I put here x. Very, very common sa atin to, ang quadratic formula. So x as the solution. We have two solutions. First, we will follow yung positive solution. So that's 5.5. Now, knowing the value of your beta 1, which is 0.8, so multiply 0.8 by 5.5, you get 4.4. Okay? Now, we check again the epsilon prime s and epsilon s. They're both good now. No? Bakit sila parehong good? Okay, good na sila because this one is not yielding 0.001, but this one is yung epsilon s. That's 0.01, which is greater than 0.002. So we say it's good also. Okay, good na yung dalawa. Okay, consistent tayo sa assumed strain for compression and tension reinforcement. So we can use already this formula. Okay, so applying this formula, we have Mn equal to 4,980 kip inch. Okay, convert that to kip foot, divide that by 12. Okay, now this one wasn't multiplied by the reduction factor yet. So if you multiply that by the reduction factor, you get 373.51. Okay, nasundan nyo yung solution. Any question? Class, Adrian? Okay, naka-thumbs up ka. Pam? Pam?
Sir, yung pag-recheck ng epsilon s and epsilon s prime is the same as sa condition 1. Yung process.
Oh, yeah. The same. Ito rin, itong formula na to.
Okay, thank you, sir.
Okay. May tanong kayo? So I hope all of you got this. Yeah, marami naman ako nakita na ganito yung solution. Okay na kayo? Okay, if there are no more questions. Okay pa ba kayo? Or a new topic? Stop share. Ganado pa ba kayo for a new topic? Yung stirrups or shear. Can you still take it? Yeah, okay. Meron na akong isang thumbs up. Anybody else? If I reach half of the class na naka-thumbs up, then we will continue. If not, okay. Sige. Looks like okay pa kaya. Now, I will just discuss yung first part, which is yung shear forces. No? Yung part ng slab, next meeting na. By the way, next week is, somebody told me merong break. Totoo ba yan? Do you have
Yes
that
po.
information?
Yes po. November
Okay.
2 to 8 po.
2 to 8. So starting Tuesday up to Saturday, wala, no?
Monday po.
Until Monday. Kapag ganon, your teacher couldn't give you any assignment, no? Hindi pwede, no? Kasi dapat reading lang yata ang pwede. Sige. All of you have downloaded the lecture notes. Download niyo na. Okay, good, good. Let's take another 5-minute break, okay, before we start the lecture. Okay. So Nicole is requesting for the Excel. Sure. Ibigay ko sa inyo. Sige. I will send you that para ano kayo. Alright. I'll send it later dun sa FB group natin. Ready na kayo sa next lecture? Let me share the presentation. Okay. So for lecture number 7, we have 2 topics. Stir-ups. Hindi ko naman makalimutan to. Ayan. Malakas ang ano niya, ang microphone niya. Kaya kahit hindi ko sinusuot, narinig niyo pa rin ako. Yep. Yeah. So stir-ups for shear, it says. Yung stir-ups, parang pareho yan dun sa ties. You call it ties if it's in column. Okay, pero merong special use yung what we call stir-ups. That is, it has something to do with the shear force of the beam. Okay, it's like it resists the shear forces that the beam is is carrying there. If you will look at the different beams that are subjected to shear forces or vertical forces, vertical force, your beam can fail this way. Okay, it is diagonal. Yung failure niya, no? There. Diagonal. Ito yung kung saan siya inihiwalay. Okay, now for lateral forces, the lateral forces mo, this is supposedly the shear wall. Now the failure is in here, as it is shown. This failed due to shear. Right? The shear wall should have failed pa rin. Okay, so now look at this one. This is, it says this is the typical pattern. Okay, crack pattern. It should have crack, and then from vertical, it's slow. It gradually angles to 45 degrees. Say now, because this beam is subjected to a combination of flexural forces or bending moment force and shear forces. Okay, now if you will look at the shear diagram of a simply supported beam, it is lowest at midspan. Shear is lowest at midspan, but moment force is maximum midspan. That is why if your beam would fail at midspan, it will actually be purely or mostly due to flexural stress. Okay? Yung flexural stress natin is, in this case, is horizontal. Okay? Horizontal tayo. Kaya, ang failure niya is vertical. So, parang, if it's horizontal, it tends to tear, okay, your section apart. Or the vertical cross-section. Na parang inihiwalay niya. Now, if there is an infinitesimal section doon sa beam mo, this will be the stresses. No? Ito yung shear, ito yung moment, flexural stress. Flexural stress, shear. Now, if that will be combined, okay, combine ito, this is its direction. Ano naman yung direction niya? Resultant of these two forces will be this. Resultant nito, ito. So therefore, this will be the. So now notice this is near the support. Because for this kind of beam, particularly in a continuous beam, okay, shear forces are maximum near the supports. Okay, if you have vertical, considering vertical forces. Okay, so this explains why at this region, failure is diagonal. Kasi combination na siya yung moment and shear forces. Okay, there. Ayan. Diagonal siya near the support. Okay? Because for continuous beams, this is the shear diagram. You have maximum near the support. Ito yung itsura ng mga stirrups natin. Those are the typical stirrups there. Okay? I think the second one is the most typical or yung kadalasan na ginagamit. Okay. Now, if we will look at a beam which is loaded, okay, with vertical forces, these are the cracks na ma-observe. Ayan. They are magnified here, just like the picture we've shown. Okay. And then there is crushing in here, sa upper portion. So they're actually compression failure. As we mentioned, that part of the beam are subjected to compression. Okay. Question: what is the maximum allowable concrete strain or the strain of the concrete? Epsilon of concrete, epsilon C. What's the value for that? Sige, yung answer niyo, iyan na dito sa chat. Titignan ko yung chat niyo. What's the value? Does your stress strain diagram, what's the value of your epsilon C? Di ba? 0.003. Okay, nanahan ko na kayo. There. Okay, correct. Adrian, Pam, yan. 0.003. Yun ang maximum natin. Okay, and then we have, says here, flexural shear tension failure. You know. Okay, and then, notice ninyo, it's maximum somewhere here. Pataas siya, no? Yep. It says if the stirrup spacing is given as S, then the number of stirrups crossed by the crack is D over S. The total contribution of the stirrups is then the strength of H times the number of stirrups, or Vs is equal to AVFY times D all over S. Okay? Yun ang formula ng shear contributed by the stirrups. Okay? Now, it says here, AV. AV, that's the cross-sectional area of one stirrup. Now, I think in my other drawing it's shown there. Mhm. Sorry, hindi nakapakita. Let me try to draw it. Okay. If our stirrup is drawn like this, okay, and kaya naging dalawa ito. It says equal to 2 bar areas. Okay, assuming each stirrup has 2 legs. Paano ba nangyari yun? It has 2 legs because the section, ganyan yan, di ba? Yung cut mo kasi pag ganun eh. Okay, that's your cut mo. This is the cut section. Where it is cutting, you have 2 areas being considered. Okay? So vertical yung cut, no? I mean, at an angle. Okay? It has an angle. So dalawang stirrups or dalawang areas ng stirrups ang nagko-contribute. Okay? So that's the total area of the steel that contributes to the shear force that is needed. Well, aside from the concrete. So we have, later on, we have VS, and then we also have VC. VS is for the stirrups, contributed by the stirrups. VC contributed by the concrete. Okay? So VS, we have that formula, AV times FY times D all over S. Okay? Yeah. Of course, your D is the effective depth. S is the spacing of stirrups. Now, it says here, as previously mentioned, the spacing is subject to an upper limit of D over 2. In order to prevent immediate and unsafe yielding of the stirrups, when a diagonal crack forms, the code also controls the maximum spacing of stirrups as a means of specifying a minimum amount of steel area. Therefore, the maximum spacing is controlled by either ito, okay, maximum spacing, the smaller of the two. No? Smaller of the two means D over 2, and this one, no? AVFY all over 50 times B. Okay? Now, in here, your Fy should be in PSI. Okay, note that PSI. Your V is in inches. Then your AV is in square inches. So yung the value here would be in inches. Okay? Okay, here. AVFY there. Yung contribution niya, AVFY. Here. Spacing would be S dito. So, your D, ito yan, kung ilan yung yung sakop niya rito. Ano? This is your D, and this is your D. Okay. Typical, okay, wait a second. Now, it would be best to illustrate this with an example later. And these are the formulas that we will be using. So VC, that's the shear capacity due to the concrete. Then VS, that's the shear capacity due to the stirrups. Our reduction factor is 0.85. Now, yung VU, ultimate shear, okay, we equate that to phi times VC plus VS. Now, so this one, this equation can be rewritten in this form if your unknown is VS. Required shear contributed by the stirrups. Yung VU, the VU, we get this, that this is actually the shear diagram. No? We draw the shear diagram applying the factored loads of the beam. Okay. Of course, the usual values of F prime C, that's the concrete cylinder strength. Fy, that's the yield strength of your steel. B, that's the width of your beam. D, the effective depth. AV, so yung AV, when we are looking for VS, okay, the shear capacity due to the stirrups. AV, that's 2 times the area of one bar that we use for the stirrups. And then S, that's the spacing of stirrups. Okay? Spacing ng stirrups yan. There. Having this problem, it says here a 24 feet long continuous beam must carry a uniform load of WU 7 kips per foot, which includes its own weight. So, kasama na yung own weight niya or self-weight, ito na yung total. No? If you see this U, that means this is already multiplied by yung factors. Let's say 1.7 for dead load, live load, 1.4 for dead load. Ito na yung combined dead load and live load. Okay? Now, take note, uniform load. Uniform load yan. Now, it says locate number 3 stirrups. So, you have number 3. Ito yung bakal na ginamit. Number 3 stirrups. And that F prime C is equal to 3,500 psi. Fy is equal to 40 ksi. B is 16 inches and D is 24 inches. Okay. Now, if you form the shear and moment diagram, okay, what's the length of the beam? 24. Okay, so 24 times 7 is how much? 24 times 7, 28. That's 168, di ba? 168 kips. No? If we will form the, where's the chat? Correct, 168. Now, let me draw let's draw the shear diagram. Kahit dito na lang. Okay, this is simply supported or continuous beam. Okay, this is 84. 4 kips. And in here is also 84. Yeah. Now, if you look at the shear diagram, okay, it is symmetrical. No? Symmetrical siya. Now, the advantage of a symmetrical shear diagram is you just work on this part, okay? And then whatever is the spacing here, in the left portion of the beam, we also implement that dito sa right side. Okay? So that's what happened here. Heto lang yung tinignan. And then whatever is the spacing on this part, ganun na rin yung spacing on the right part of the beam. Or the right side of the beam. Okay? Any question? Now, this is the solution. First, we have to sige. Okay. First, we have to get the VU at the critical section. No? How do we determine this? VU at the critical section, that is this region. This region. So in here, ito yan. Now, so to determine that critical region, that will be the region D away from the support. From the support up to D, okay, away from the support here. So by ratio and proportion, we get yung 70 kips. Okay, kaya dito 70 kips siya. From 84 kips, we get 70 kips. Okay, class, let me ask, it is clear naman how we got this 84 kips na. 84 kips. This is from the shear diagram. Okay. Total vertical force is 168 divided by 2. Paghahatian ng dalawang support sa left and right end, magiging 84. Tama? So 84 kips siya. Now, identifying the critical region, which is 24 inches, the D away from the support. So therefore, eto yon 70 kips na. 70 kips, that's the critical region. Okay, later on, we will find that the spacing at the critical region is 5 inches. Okay, but we have to identify where the now, what is the value of your U at that region? Where purely VC now, or the shear capacity given by concrete now, is multiplied by phi, the reduction factor, which is 0.85, and then it is divided by 2. I-divide pa siya ng 2. First, we have to get VC. Your VC, this is the formula. 2 times the square root of F prime C times B times D. Okay? B is the width, D is the effective depth. So we get that as 45,400 pounds. Okay, or 45.4 kips. Now, getting VC over 2, you have substitute phi 0.85 times 45.4 divided by 2, you get 19.3. Okay, that's 19.3. Now, by ratio and proportion, okay, how do we do that ratio and proportion? From here, no? Ito, we take this triangle, okay, 84, 84 over 144 unknown length, no? Which is later on you got as 33 inches. There. Doon natin nakuha yung 144. 120, 144. Ah, sandali. Confused ako doon. Dito tayo. X over 19.3, 144 over 84. So X is equal to 33.1. Again, let me show that. 19.3 yung X dito. That's the X. Okay? Ito yung X na. I'll just show that we are considering this triangle and this triangle. Ganito kaya. Straight line. Okay? So, similar triangles sila. That is why you can do the ratio and proportion. Ratio and proportion. Yeah. That's why we got 33 inches. Okay? So, from midspan, this is the midspan, up to 33 inches. From the midspan, you don't need any stirrups. The concrete will take care of the shear forces there. Okay? Now, from that point, okay, up to a certain region, your spacing is S max. Now, how do we compute for S max? So S max, we have to determine which is lower than the 2. Okay, so we compare D over 2 and AVFY 50B. So AV is 0.22. Actually, one cross section of a number 3 bar is 0.11. As we said, we are considering 2 cross sections of that stirrups. No? Yung cross section ng stirrups natin. So 2 times 0.11 is 0.22. So that's the value of your AV. Now your FY is 40,000. All over 50 times 16. Yeah. So you get 11 inches. So we have to choose for the lower value. Okay, so that will be your maximum spacing na natin. So that's 11 inches. Now, we determine where the 11-inch spacing can start. Okay. It says all spacings from this location back to the support will be smaller. The 11-inch spacing will give us, okay, considering the spacing to be 11, the shear force actually would be, shear force that it will be contributing is computed this way. So we use this formula, AB, that's 0.22, FY is 40, and then your D is 24. Okay? So you get PS equal to 19.2 kips. Now, to get the corresponding shear capacity, we apply this formula. So this is 0.85 shear capacity due to concrete. That's 45.4. We've computed that already. And then this BS, considering this, that's 19.2. So therefore, your VU will be 54.9 kips. Okay, so now we have to determine where that 54.9 is. So again, this is ratio and proportion, 54.9. Now let me go back. Ito yung 54.9. It's the B. Now, at first, we don't know this yet in 94. No, but we are actually considering this. No? Itong triangle na to. By ratio and proportion. Okay, those are similar triangles. No? There. And we get 94 inches. Okay, now we computed 94.1. Now, we round down. No? Ito kasi we're talking about spacing. So, yung 94 inches naman is measured from at the midspan of the beam. So, if you round down, you're actually being conservative. Okay, nagiging conservative ka. Ilalapit mo yung mga stirrups mo sa midspan. Okay? So, 94 inches. It says here, since the beam half is 144 inches, this point will be 50 inches from the support, sabi niya. 50 inches from the support. Let's look at that. 54.9. This is 94. So, malapit na siya. 11-inch ang spacing nito. Now, we will have to solve for the minimum spacing. Find the minimum required spacing at the critical section. So we have VU 70 kips. Okay. We consider this VS is equal to kung ilan yung shear capacity due to the steel. You know already your VC, you know already your VU. So plug in the values, you get PS 37 kips. To get the spacing, knowing our shear capacity, there. We have this formula. So spacing is equal to AB FY D all over VS. Now just plug in the values, you get 5.7 inches. Now, this is spacing. To be conservative, you have to round it down. Hindi pwedeng round up yun. Okay? Because if you reduce the spacing, you're actually becoming conservative. Na pag nilakihan mo, you won't suffice the needed shear capacity due to the steel. So 5 inches. Okay. So from 5 inches, yung kanina, ilan yung spacing dun sa maximum? You have 11, di ba? So you can still have a spacing between 5 and 11. Okay? So you just add the 2 and then divide it by 2. 5, 11, that's how much? 16. Pwede 8. In this case, it used 7. It says logical choices for this emergency spacing. What would be the PU? So and where it should start. So again, we given the spacing 7 inches, we compute for VS. The VS is 30.2 kips. Applying that, you get 64.3 kips. Now going back to our drawing there. Ito yung critical region natin, yung 5 inches spacing. Now, for the 7 inches spacing, saan tayo mag-start? 110 yung na-compute natin. 110, that will be 7 inches spacing. And then, from that portion to the left support, you will implement the minimum spacing, which is 5 inches. Okay? So this is the effective spacing of the stirrups at the left portion of the beam. No? So we will also use this doon sa right portion natin. Kasi symmetrical lang naman. Okay? Any question? So just follow the computations. It's not hard to understand them. Okay. There. Now, how do we implement this? Now, it says here 7 at 5 inches because this is 34 inches. 34 divided by 5 is how much? 6. Tama? But then, gawin mo ng 7. Yung, dulo-dulo, yung tigpa 5 inches. So, 1, 2, 3, 4, 5, 6, 7. Now, itong 2 inches, okay, kasi yung first bar from the support, yung 2 nakuha natin sa 5 divided by 2. Kasi the section that we are considering is 5 inches. Now, we place it not at 2.5, but you go further para hindi na mahirapan yung carpentero. 2.5 inches pa niyan. 2 inches mo na siya ilagay. No? In that case, you are being conservative again. From 2.5, ginawa mong 2. So that's where your first tier up is located. And then the next one is 5. So 2 plus 1, 2, 3, 4, 5, 6, 7. No? So 7 times 5 is what? 1, 2, 3, 4, 5, 6, 7 times 5 is around 35. Or 34 lang nilagay niya rin. Anyway, then the next stirrup would be 7. So from here, 7 inches, 7 inches. Let me write that down. Ito. This is 5. This is 7. Mhm. There. Tapos from here, you have 11. No? Of course, from here naman, no stirrups dun. Okay? From here up to center line, wala kang stirrups. Yeah? So, that's how we do it. Any question? Question. Another example. Okay, medyo inabot na tayo ng 12. I might tire you so much. No? I don't want to do that. So we'll just continue next meeting. Next meeting natin will be when? Okay, you can open your cameras, please, so I can take a picture of you. There. Okay. Waki tayo, waki. Alam mo, masaya. Kasi meron kayong break. Kaya dapat, sige, DJ is okay. Yan. Okay, ready na kayo? Sige, I'll just take a picture. Chat. I-off ko muna yung chat para malaki. Ayan. Asa na rin. I-capture ko muna kayo. 1, 2, smile. There, okay. Hindi nga. Paano kung ano yan? Yan. Yan. Okay. Do you have anything gusto nyo i-raise sa class natin? Are you, okay lang naman yung lecture natin? Hindi naman kayo masyadong nabibigatan? Okay. So, carry lang, di ba? After all, hindi naman ganun kahirap. Yeah, just in case there's a portion that you need to clarify or you want to discuss again, you can just message me, okay? And if needed, I can meet you separately so we can explain further, okay? Maybe it's not too late kung if I will just give you your first quiz Tuesday, November. That would be November 9. November 9, first quiz. Kasi yung November 2 to 8, hindi ko kayo pwedeng bigyan ng ano. But I can give you hindi rin pala pwede. Okay, just read the lecture. You also have the book. Read the slides and you do your project. So you have something to do over the weekend and up to the break, during the break. No? And then, kasi nakapag-solve na rin naman tayo ng mga problems. So I think sige, November 4 na lang yung quiz natin. Okay? But since it is take home, I can meet you November 2, tapos bigay ko na lang ng 4. Then after 2 nights, you can submit online. Okay ba yan? Sorry. November 9, I'll meet you November 9, and then November 11, bigay ko yung exam ninyo. You submit it November 13. Okay yung schedule? Okay. Para yung hindi kayo masyadong bigatan. Yep. Sige. Siguro na. Bye-bye.
Thank you, sir.
Thank you.
Sir.
Yes, sir.